In this video, we're going to be finding the initial amount and rate of change given a graph of a linear function. Keep in mind that the initial amount occurs at the beginning. That means time equals 0. And the rate of change is the slope, which I will remind you is rise over run. And if the slope's headed downward as you move left to right, then it will be a negative slope. Okay, so let's read this. Scientists are measuring a distant planet's temperature. The graph shows the temperature in Celsius versus the height in kilometers above the planet's surface. What is the temperature at 0 kilometers? Okay, so here's the height, 0 kilometers, 1 kilometer, 2. It's going up as we go. So the height's getting greater. And here's the temperature, 5, 10, 15, 20. Okay, so at height, or at what is the temperature at 0 kilometers? That would be here. Height would be 0, so the temperature is 45 degrees Celsius. Okay, and now it says choose a statement that best describes how the height and temperature are related, then give the value requested. Okay, so the first one says as the height increases, the temperature decreases. Okay, let's see if that's true. As we move, if we start at 0, the temperature is 45. If we move to 1, or actually let's move over to 2, the temperature is 25. We move over to 4, the temperature is 5. So yeah, as the height gets bigger, the temperature is decreasing. What is the rate at which it's decreasing? That means we need to find the slope. So this is the one that we choose. We need to find the slope. So we look here, that's 45. And if we go down twice, it intercepts right there on a corner. So we can use those two to determine our slope. So it goes down how much? From 45 to 35, that's down 10, right? And in that same time, it went over how much? Just 1. So negative 10 over 1. So negative 10 per kilometer. Okay, oh, it did say the rate at which it's decreasing, so let's leave out the negative, okay? If it said at what rate is the temperature changing, then we would need to say negative because it's going down. But since it said what rate is the temperature decreasing, that takes care of the negative sign in the problem already, and we just need to give a number, okay? And we don't use this because that wasn't the choice that we chose, okay? Let's look at this. At a candy factory, a machine is putting candy into a container. The graph shows the amount of candy in pounds in the container versus time in minutes. So the first question is, what is the amount of candy in the container at 0 minutes? Okay, so 0 minutes means right here. That's 0 minutes, right? So how much candy is in there? It looks like 120 pounds. Okay, now we need to choose one of these to see how these two are related. As time increases, the amount of candy in the container decreases. Well, let's see. We start at 0, it's 120. If we move over to 1, it goes up to 200. So increase, and then also increase. So it looks like as the time goes by, then the amount increases. So that's not this. This says as time increases, the amount of candy decreases, but this is a positive slope. So that can't be that one. So we'll throw that one out. We'll choose this one. As time increases, the amount of candy in the container increases. And now we just need to find that slope. Okay, so it looks like it crosses at a corner right there and right there. So we can use those two numbers as a slope, or we could use these two numbers, or these two numbers, or these two numbers. It doesn't matter. Just pick which ones you want. So I'll just use this. It says, as I move over once, how much did I increase from 120 to 200? I increased 80. So every minute it increases by 80. So at minute 2, it's all the way up here at 280. So increased another 80. After another minute, it should be another 80, which would be 360, and that works. Okay, so it's 80 pounds per minute is the rate that it's increasing.